Section 7.6 is about solving rational equations. And so because this is a rational equation in one variable, we need to have each side written as a rational expression. So for example, x plus 3 over x minus 1 is equal to 2 minus x squared plus 4 x minus 3 over x squared minus 4, for example. The difference between the rational equations and the expressions we were dealing with before is the equal sign, of course, and the ability to solve for x. So what we're looking at doing here is using the same technique we used when we had equations involving fractions. We're going to clear the fractions. So to clear the fractions, we're going to multiply by the LCD. Multiply by the LCD. So the LCD in this set of fractions right here is 6. So we're going to multiply everything by 6. So remember that this might look like 6 times x minus 2 plus 6 times 8/3 equals 6 times 1/6. So what we're doing is multiplying everything by 6, making sure that our 6 gets distributed to every single piece. Now, 2 goes into 6 3 times, 3 goes into 6 2 times, and 6 goes into 6 1 time. So the result is 3x plus 2 times 8 is 16 equals 1 times 1 is 1. Now I continue to solve it like a regular equation, subtracting 15 from both sides. I'm sorry, subtracting 16. I was already thinking ahead to what I was going to get. Subtracting 16 from both sides to get 3x equals negative 15, and then dividing by 3. So in this one, the answer was, that's an arrow, it's a really bad arrow, but whatever. The answer is negative 5. Okay, so we're going to just use that same technique to solve our rational equations. So the least common denominator, or the denominators of x and 2, is going to be 2x. So we're going to take 2x times 9 over x minus 1/2 equals 4. We're going to make sure that we multiply 2x by every single piece. When I multiply 2x by x, the x will cancel, leaving just the 2. 2 times 9 is 18. When I multiply 2x by 1/2, the 2 will cancel, leaving just the x. So 1 times x equals, and 2x times 4 is 8x. Now we solve this like a regular equation. Get all of the x's on one side. So 18 is equal to 9x. And if I divide both sides by 9, I get 2 for my x. Alright. Now with a rational equation, it's possible to solve the equation just like normal, but still arrive with an x value that's an excluded value for the function. These values of x's are not solutions since they're not even possible to plug into the original equation. So we call these values of x extraneous solutions. We don't want to get any extraneous solutions. We better check to make sure that our solution wasn't extraneous. Extraneous just means that it's an extra solution. It looked like it was going to be one, but is not actually one. Okay. So it's very important that we always check that any proposed solution is not an extraneous solution. So if I go back to that last problem, the only extraneous solution would have been a number that would have made the bottom 0, and that meant that the only extraneous solution in this case was 0. X cannot be 0 because 0 would make the bottom 0. Since I didn't get 0 for an answer, I'm good. My answer is 2. Okay. So here are the steps for solving a rational equation. Factor first. I need to factor before I can talk about LCD, and I also need to factor so that I can identify any excluded values or possible extraneous solutions. Okay. So these 3 steps are related to factoring. Then I need to multiply both sides of the equation by the LCD, and then solve the result. Discard any proposed solutions that are excluded values. So let's take a look. The first thing to note, well, the bottoms don't need to be factored. So I'm going to note my extraneous answers. I'm going to note the excluded values. X cannot be 0, because a value of 0 for x would make the bottom 0. Okay, x isn't 0. Let's find out what it is. The LCD is x, so we're going to take x times everything. So 8 over x minus 3 equals 4 over x minus 1, multiplying that x into everything. Okay. So x and x cancel, just gives me 8, minus x times 3 is 3x, equals, x goes into x once, so I get 4, and then x times 1 is x. Okay, so let's just start solving. I'm going to add the 3x to both sides. So that gives me 8 equals 4 plus 2x. Subtract the 4. 4 equals 2x, and then divide both sides by 2. 2 is my x. That is not the extraneous solution, so that is the answer. Okay, look at the next one. The extraneous solution here is that 6 times x cannot be 0. So if 6 times x can't be 0, again, x can't be 0. Let's multiply everything by the LCD. The least common denominator here is going to be 6x. These are just monomials, so I'm not worried about factoring. So I've got x over 3 minus 5 over 6x equals 1/2. We're going to make sure to multiply everything by this 6x. 3 goes into 6 twice, so that's 2x times x is 2x squared. 6 goes into 6 once, the x also cancels, so that gives me just 1 times 5. And 2 goes into 6 3 times, so that's 3x times 1 is 3x. Okay. It's got an x squared, so to solve it, I want to get it equal to 0. So x squared minus 3x minus 5 equals 0. We just subtracted the 3x to the other side. Now we're going to factor. So we'll factor by starting off with 2x and x. I'm going to make a 2x with a 2 and a 1, and then we'll put the 5 and the 1. Let's try this out. 5 and 1 here and here. So that'll make 2x, that'll make 5x. If I want it to come out to be a negative, I better have that 5 be negative and the 2 be positive to get negative 3. So that's going to be the right factoring there. Okay, so let's get rid of this checking from the trial and error. And this is supposed to be equal to 0. So then I set each part equal to 0. So that means 2x minus 5 equals 0, or x plus 1 equals 0. So if I add the 5 over, 2x equals 5, divide by 2, so that would be x equals 5/2, or subtract 1 from both sides, x equals negative 1. Now neither of those is my excluded value. My excluded value was 0, so that means that both of them are good. 2 answers, 5/2 and negative 1. Alright, let's look at some more on the next page. Okay. Now the excluded value for this equation is going to be 2, because when I plug 2 in for t, 2 minus 2 is 0. So t cannot be 2. Okay? It's already factored, so t minus 2 is the common denominator. We're going to multiply everything by t minus 2. So it's 2 minus 1 over t minus 2 equals t minus 3 over t minus 2. All of that's getting multiplied by t minus 2. So t minus 2 is going to get multiplied into all 3 parts. In the first part, 2 times t minus 2 is 2t minus 4. Just bring that 2 in there. In the second part, the t minus 2 is going to cancel with the t minus 2 and give me minus 1 equals t minus 2 cancel the t minus 2 to give me t minus 3. Okay, let's start combining like terms. This is 2t minus 5 equals t minus 3. Subtract t from both sides. It gives me t minus 5 equals negative 3. And then we'll add 5 to both sides to finish this off. Okay, so this gives us t equals 2. But remember that t couldn't be 2 So my answer here is nope, that's the extraneous solution. So since I don't have an answer that isn't an excluded value, I have no solution. Because if you tried checking that, if you tried plugging 2 in, you would get, real quickly, when you plug it into this part right here, you would get 1 over 2 minus 2 is 0, 1 over 0 is undefined, you can't check it, it's not going to work. Okay, so this problem has no solution. Okay. Alright, let's try again with the next one. Y plus 1, the value that would make that undefined is negative 1. So y cannot be negative 1. And let's multiply everything by y plus 1. So y plus 1 times 8y over y plus 1 equals 4 minus 8 over y plus 1. Y plus 1 times y plus 1 is 1. Y plus 1 goes into y plus 1 one time, so that gives me 8y equals 4 times y plus 1 is 4y plus 4 minus y plus 1 goes into y plus 1 once, so 8. Combine like terms, 8y equals 4y minus 4. Subtract 4y from both sides. It gives us 4y equals negative 4. If you divide both sides by 4, you get y equals negative 1. So this is another example here of no solution. Y cannot be negative 1. So the correct answer to this problem would be no solution. Alright, let's look at a couple more examples, C and D right here. Okay, we know that p squared minus 9 can be factored as p plus 3p minus 3. So my excluded values are p cannot be 3 or negative 3. I've got two excluded values this time. If you plug a negative 3 into the either of the p plus 3s, that would give you 0. If you plug a positive 3 into either of the p minus 3s, that would give you 0. So there's two excluded values. And the least common denominator is the p plus 3, p minus 3. Okay, so we're going to multiply that by everything. So by 6 over p plus 3, p minus 3. Plus 1 over p plus 3 equals 1 over p minus 3. Okay, and distribute. In the first piece, p minus 3 and p plus 3 will both cancel. We'll just have 6 left. Plus p minus 3 will cancel. So p plus 3 will cancel. So we'll just have 1 times p minus 3. Equals p minus 3 will cancel, we'll have 1 times p plus 3. Okay, so I don't really need the 1's there, just wrote them just in case there's a different number there in the next one. So this is 6 plus p minus 3 equals p plus 3. Okay, so let's combine like terms. We have p plus 3 equals p plus 3. This is oddly suspicious. If I subtract p from both sides, that gives me 3 equals 3. Okay? This, when we were looking at equations in one variable, this was the all real numbers are solutions type. Everything works, but we already know that these two numbers don't work. 3 and negative 3 don't work. So my answer is all real numbers except 3 and negative 3. So 4, 6, 10, any number that's not 3 or negative 3 works. So I need to write that whole statement out. It's not all real numbers or infinitely many solutions, which I would have said in chapter 2, but it's all real numbers except for those two values that are excluded.